You're driving along the freeway at exactly 50 miles an hour. You keep going for exactly 3 hours and then you stop instantly. Ignoring the angry drivers behind you, how far have you gone in those 3 hours? I think you'll tell me exactly 150 miles, right? Because 3 times 50 is 150. And that tells me you already understand what this module is all about. Most of the concepts are right there in what you already did. You said the distance is equal to the speed times the time. By rewriting that as d equals s times t, we have an algebraic formula for d. And you already know how to get from there to a formula for s or a formula for t. In the module on formulas, you learn to isolate one of the letters by treating the rest of the equation as numbers. The first step is an easy one. Simply for convenience, let's reverse our distance formula before we solve for speed, or s. Remember, an equation is true no matter which direction we read it. To isolate the s, we divide both sides by t and cancel. That gives us the formula for speed. Speed equals distance divided by time. To find the formula for t, use the same starting point. We divide both sides by s, and we cancel, giving us t, or time, equals the distance divided by the speed. Simple enough, right? If not, you would be wise to take another look at the module on formulas and then come back to finish this module. 3 formulas: for distance, for speed, and for time. Each shows the relationship of one variable to the other 2. Be aware that you may see these formulas with an r in place of the s. That stands for rate, which is the same as speed. d equals st. We might say something like, Denver steaks are tender, as a memory trick to help remember the formula. Here's another memory trick for remembering all 3 formulas. Write them inside a triangle as dst. The triangle gives you all 3 formulas, because for each letter, it shows you the position in the formula of the other 2 letters. Take d at the top. d equals s next to t, or s multiplied by t. s equals d over t, or d divided by t. And finally, t equals d over s, in the triangle and in the formula. Incidentally, the speed we're talking about here must be either constant or an average speed. We assume it's exactly the same speed at all times. Changing speeds are much harder to handle. For now, we're going to stay with one speed at a time. Now let's apply our Denver steaks are tender memory trick to another word problem. Your surfing friend Randy pops into your room, raining sand everywhere, and says, "Hey dude, I made it home from the beach in 35 minutes. Well, it's 30 miles to the beach, and you know the speed limit is under 45 miles an hour all the way. Just how fast was Randy driving? What was his average speed? Well, you can pull out the formula from your distance triangle. S equals d over t. Plug in the values that you have for distance and time, simplify, and we get 6/7 miles per minute. To get a more familiar miles per hour, we multiply by 60. And tell that Randy he was well over the speed limit. Randy says, "Whatever. Hey, I'm off to a surf comp in Hawaii, so aloha." And he flies the 2,350 miles from San Francisco to Honolulu at 450 miles an hour, which leaves you with another question. You know the distance and the speed. How long does it take Randy and his surfboard to reach Honolulu? Pause the program while you work out your answer. Click play again when you're ready to compare solutions. Denver steaks are tender, dst. In this case, it's time I'm after, so t equals d over s. The time equals the distance divided by the speed. Substitute our values for the letters and solve for t. Since the speed was in miles per hour in the first place, the answer comes out directly in hours. Randy was in the air just over 5 hours. Pretty simple. Now let's try something harder. Let's say that you live outside the city, even a couple of miles beyond the bus line. Your car is in the shop, so you have to walk 2 miles to the bus and then ride 6 miles to work. If you walk 2 miles at 4 miles per hour and ride 6 miles at 18 miles per hour, what is your average speed for the entire journey? Clearly, the trip happens in 2 parts, at 2 different speeds. It would be nice if we could simply combine the 2 speeds, but the distances differ as well, so we cannot. What can we do? What do we always do? We use what we know, and we take it one step at a time. To find the average speed for the entire journey, we need to divide the total distance by the total time. We know how to find the time for each part separately. Refer to our trusty triangle. Let's do the walk first. The distance is 2, the speed is 4. 2 divided by 4 is 1/2. So the walking time is 1/2 hour. The bus ride is 6 miles at 18 miles per hour. Using our formula, we see it takes 1/3 of an hour. Now, how long does it take you to get to work, walking and riding? Well, if your walking time is 1/2 hour and your riding time is 1/3 of an hour, then your walking and riding time must be 1/2 plus 1/3 of an hour, which is the same as 5/6 of an hour. Now we have the total time, and the total distance is simply the sum of the walk distance and the ride distance, or 8 miles. Those are the numbers we need to get the overall speed, the average speed we're looking for. The speed equals the distance divided by the time. 8 miles over 5/6 of an hour can be rewritten with an ordinary division sign like this, 8 divided by 5/6. How did we solve that when we did fractions? We turn the fraction over and multiply. 8 divided by 5/6 is 8 times 6/5, or 48/5, or 9 3/5. So 8 miles covered in 5/6 of an hour gives us an average speed of 9 3/5 miles an hour. Let's review what we did here. Wherever we had 2 values, we used a formula from the DST triangle to get the third value. But we could not use that on the whole problem at once. We could easily find the value for D, but not for T. So we divided the big problem into smaller parts, and we got a T value for the walking part and then for the riding part, and then we were ready for the whole problem. In other words, we followed the most basic rules of all. Look for ways to apply something you can do. Do one thing at a time, and above all, do not panic. See if you can use these rules on this problem. You take a weekend off from algebra, head for Yosemite, and go backpacking. You climb out of the valley, slowly, zigging and zagging upward for 16 hours at a constant speed. You come back down on a different trail. You are going 3 miles per hour faster, and it takes you just 8 hours to make the trip down. The question: if the total distance you hiked was 30 miles, up and down together, then what was your speed on the way up? These hints should be all you need to do this problem. Use what you know, don't panic. Pause the program when you have your answer, click play again, and we'll compare solutions.